Bonjour baddies, welcome back to another video. It's problem number 18 of the 2015 AMC 10A set. Hexadecimal base 16 numbers are written using numeric digits 0 through 9 as well as the letters A through F to represent 10 through 15. Among the first 1000 positive integers, there are n whose hexadecimal representation contains only numeric digits. What is the sum of the digits of n? So the first course of action that we can take in this method is converting 1000 into hexadecimal form. So the first step in doing that is basically finding out how many powers of 16 we can fit in 1000. Since 16 to the power of 2, or just 16 squared, is equal to 256, if we multiply by another 16, aka 16 to the power of 3, it's obviously going to surpass 1000, because multiplying by even 4 would surpass 1000. Therefore, this means that the greatest amount of 16s that we can cram in 1000 is 16 squared. This means that we basically have 16 to the power of 2 multiplied by some number, plus 16 to the power of 1 multiplied by some number, plus 16 to the power of 0 multiplied by some number. And that is going to be 1000's hexadecimal form. So the reason why we're converting 1000 into hexadecimal is that it usually makes the range a lot smaller for our numbers, and specifically because a number converted into hexadecimal form, since it's base 16, from base 10 to base 16, it gets smaller because there's less 16s in a number than there are 10s. So converting 1000, we basically just have 1000 divided by 16 to the power of 2, which is just 256. If we try 3, we get 3 times 6, which is 18, 3 times 5, which is 15, plus 1, which is 16, 3 times 2, which is 6, plus 1, which is 7. So just solving this, we get, just gotta get all of that over, 9, 9, 10, 2, 3, 2. 232. But the thing we need to focus on the most in this is the 3, which means that since there are 3 16 to the power of 2s, our first number in our hexadecimal form is 3. So 3 to the power, multiplied by 16 to the power of 2. So our second step is dividing 232 by our next power of 16, which is just, 16. So you have 232 divided by 16. So we start with 1 because 23, so we have 16. This is plus 7, 72. And then we have 4 because 64, we have 64 down here. And then 6 plus 2, which is just 8. So we have 14 and 8. 14 in hexadecimal is represented as E, and the 8 is just, 8 in hexadecimal. So this is 1000's hexadecimal form. And the reason why we're finding this is because it narrows our range down for quite a bit. So basically, any number under the sun, under this, works, but we need to make sure that it also doesn't have any non-numeric digits in it. So this basically means that we can't use any digits that are greater than 9, because that's 10, 11, 12, 13, 14, and 16, 15 and 16 all include letters, and we're not allowed to use that. It has to be a 3-digit number, of course, because 1000 is already a 3-digit in hexadecimal, so we can start concocting how many we can make. So for our first digit, we have everything from 0 to 3, because you could just have 0 multiplied by 16 to the power of 2, so it just doesn't go into 16 to the power of 2. But enough yapping, it's basically just 4, because 0, 1, 2, 3, 4. 0, 1, 2, 3, sorry. And then for E, we can't have anything above A, which means that we only have 0 to 9, which means we have 10 numbers. And since above E, we can basically just let 8 borrow everything, it can't possibly surpass something with E in the power of 10, no matter how many ones digits we put down. So you basically have free reign with the last digit as well, so we have 10 as well, from 0 to 9, because we can't go past 9. So it looks like we have 400. However, it also happens that 4 plus 0 is not an answer choice. This is because this fails to acknowledge the fact that it also uses 0, 0, 0 as an answer, which is not a valid answer because that would just be 0 and it says positive integers. So we have to subtract 1, getting our answer to be 399. Then adding 399 together, we basically get E, which is 21. So our answer is 3 plus 9 plus 9. So yeah, that's the end of this video. Hope you guys enjoyed, and I'll see you all on the next one. Bye bye!